need to expose search functionality, where some parameters should be client configurable, while others remain fixed. You'll see how FastMCP's URI templates let you selectively expose parameters, like making max results optional in the query string while keeping other defaults hidden. The pattern shows two identical search functions, where one allows client overrides and the other doesn't, all controlled by the URI template syntax.
Hash clients can override max results via query string. At MCP, resource, search//query max results. Def search configurable query, SDR max results, int equals 10, dict. Return query, query limit, max results. Hash clients cannot override max results, not in URI template. At MCP resource, search//query. Def search fixed query, SDR max results, int equals 10, dict. Return query, query limit, max results.
This demonstrates parameterized resource templates using RFC 6570 URI patterns, a technique for exposing dynamic data endpoints with configurable behavior. The key concept is treating URIs as templates where path segments and query parameters become function arguments, enabling clients to request variations of the same resource without hard-coding each possibility. What makes this distinctive is the declarative mapping between URI structure and function signatures, creating a REST-like interface with Python's native type system. The approach works by establishing a contract between URI patterns and function parameters, where path parameters become required arguments and query parameters become optional overrides. FastMCP handles the URI parsing, type coercion, and parameter injection automatically, while your function remains focused on business logic. This separation of concerns means you define what data is available and how it's structured, while the framework manages the transport and parameter handling. This pattern solves the problem of exposing configurable data access points without creating an explosion of similar endpoints. It's particularly valuable when building systems where clients need flexible access to parameterized data, like search interfaces, user profiles, or API gateways. The trade-off is that complex parameter validation must happen within your function rather than at the URI level. But this keeps the interface simple and predictable for clients. Let's break it down line by line.
Hash clients can override max results via query string. At MCP, resource, search//query max results.
This URI template enables client override of max results through query parameters. The max results syntax makes the parameter optional in the URL, allowing clients to specify a custom limit while maintaining the default fallback. This pattern keeps the API flexible without requiring separate endpoints for configurable limits.
Def search configurable query, SDR max results, int equals 10, dict.
This defines the search function with a configurable limit. The max results parameter defaults to 10, but can be overridden via the URI template, giving clients control over pagination. This is the standard pattern for optional query parameters in FastMCP endpoints.
Return query, query limit, max results.
This returns a standardized response dictionary that separates the search query from its result limits. The structure ensures consistent output regardless of whether max results was configurable in the URI template, maintaining predictable behavior for clients.
Hash clients cannot override max results, not in URI template. At MCP resource, search//query.
This URI template deliberately omits max results from the path, making it a fixed parameter. Clients can't override it via the URL, enforcing consistent behavior regardless of input. This pattern locks down configuration when variability isn't needed.
Def search fixed query. SDR max results, int equals 10, dict.
This defines the fixed max results search endpoint. The URI template excludes max results as a query parameter, preventing client overrides. The default value of 10 becomes immutable for all calls to this endpoint.
Return query, query limit, max results.
This constructs the response dictionary with the query string and result limit. The consistent structure ensures predictable output for clients, whether they can override max results or not. This pattern maintains API contract stability across different endpoint configurations. Resource URI design pattern. FastMCP's URI templates bridge Python functions and network resources, where path parameters enforce requirements while query parameters expose optional configuration. Parameters in the URI template, but missing from the function signature trigger validation errors during server startup. The URI template becomes your function's public contract. What's visible defines what clients can control.
The parameter that vanishes from the template gains absolute control.